All right, good morning, everybody. So remember in the last class we were talking about we were starting to learn about how to use objects. So I'm just going to quickly review the last few slides from the previous lecture. So remember that to use an object, the programmer needs to make an object. Once they've created the object, they can then use the object, and eventually at some point, someone has to destroy the object because objects occupy memory and other computing resources that you need to return back to the computing system. So in Java, the programmer is responsible for creating the object. They're responsible for using the object, but destroying the object is left up to the Java virtual machine. Okay, so to make an object, for the purposes of this course, you always need to call new. Someone has to call new. You might not have to call new directly. So for example, you might use a method somewhere, but inside the method, you might use a method somewhere that returns a new object, but the method inside the method, there will be a call to new somewhere. Right? So new does three things. It allocates memory for the new object, right? So all objects, well, most objects have data. So that data occupies memory. New needs to allocate enough memory to hold that data. New then calls a constructor, and the constructor is responsible for initializing the object. So it's responsible for initializing the data that the object has. And then it returns a reference to the new object so that the programmer can actually use the new object. Right? And so here's an example. Here's three examples of using new. Right? So here we've got 3 points, P1, P2, and P3. Right? The first point, on the P1 is created by using the new operator, calling a constructor. And that particular constructor sets the state of the point to 0, 0. Right? The second constructor sets the state of the point to 1 and 0.5, and the third constructor copies the point P2. And so it makes a third point whose coordinates are also 1 and 0.5. And here you've got three independent objects. Right? If the programmer changes the state of one object, in this case, the state of the other objects remains unchanged. So for example, if the programmer changes the coordinates of point P3 to say 2 and 25, the point that was copied, P2, its state doesn't change, right? It stays the point. Its coordinates remain 1 and 0.5. All right, so we'll just skip over all of this because this should all be review. Here we go. So this is where we left off. All right, so once you've made your object, so you've called new, you've called the constructor, you've got your object, you've got a reference to an object, you can now use the object. So in this course, the way that you use an object, there's only two things that you're going to do with it. You're either going to access its data directly, so you're going to look at one of the fields of the object, or you're going to ask the object to do something. And so the way you ask an object to do something is you call a method. Right. All right, so using an object usually means calling a method, and the way that you call a method is you've got a reference to an object, right? So that's typically a variable, right? Then you write dot, and then you write the name of the method, and then you pass in the arguments to the method. You may have done something like this in 121 if you happen to use one of the list methods, or possibly a string method, I suppose. But you may not have as well. Right? So the dot operator is used to access something belonging to an object or class. Yes, so sometimes instead of accessing a method, or instead of calling a method, you're going to access one of the pieces of data that the object has directly. Right? And so for that, you write dot and then the name of the variable that you want to access. So we'll look at examples of both of these shortly. All right, so here's an example of using the point class, the point2 class. So remember, point2 just represents a two-dimensional point. Right? So it has an x and a y coordinate. If you are looking at the source code that you can download for the course, you can see the full implementation of point2 and everything that it can do. For now, we've got a constructor. Right? So the constructor makes a point whose coordinates are 0.5 and 0.1. Now for point 2, you can't access the x and y coordinates directly. So you're not allowed to ask, you can't get to the variable that p uses to store its x coordinate, and you cannot get to the variable that that p uses to store its y coordinate. Right? But you can ask the point for its x and y coordinate. So the way you do that is you call a method. So you ask p, what is your x coordinate? Right? And that returns 0.5. Right? On the next line, we're going to call the method called y, right? And so that asks p for its y coordinate, right? It's a method call here, so you need the round brackets. Right. If you want to change the coordinates of p, we can change x and y. So I can add 0.1 to y, I can subtract 0.1 from y, or something else. Right? And then I can ask p to change its coordinates to the new x and y. So the way you do that is you call another method. So the point2 class has another method called x, but the second method takes in a new x coordinate, and that changes the coordinate of the point to the new x coordinate. So p.x, round brackets x, changes the x coordinate of p to 0.6, right? And p.y, round brackets y, changes the y coordinate to 0 in this case, right? 0.1 minus 0.1. Right? There's also a set method in point2. So set lets you set both the x and the y coordinate with a single method. Right? So that one line there is equivalent to the first two lines, to the previous two lines. So those are just some simple examples of using methods that belong to an object. Here's a slightly more complicated example. I'm not going to bother explaining this. All it does is it moves the x coordinate of the point continuously, and it causes a point to go, this one draws a point that moves back and forth on the screen. I'm just going to run it for you so you can see what it does. So there's the class, there's the main method, and using a point. So I'll just run it and see what we get. And so here I'm drawing the point as just a big circle, and it just bounces the circle back and forth. Right? So when the x coordinate of the circle reaches the right-hand edge, it simply reverses the direction that the point is moving in. Right? When it hits the left-hand edge, it simply reverses the direction that the point is moving in. Right? And it's a very small program that does this. Right? So it just sits in an infinite loop. Right? So while true, we're going to ask the point, what is its x coordinate? Right? And we're going to move it by some amount dx. Right? So dx here is set to 0.01. When we want it to move to the left, you just change the sign of dx, so you make it negative. Right? When you want to move it to the right, again, you change the sign of dx, so you negate dx. Right? And that causes the ball to bounce back and forth. You can see down here, this is where the drawing is happening. And so the drawing, I'm using this class called Standard Draw that was written by somebody at Princeton. And it's got a bunch of methods that let you draw simple geometric primitives. You'll be using that, I think, on assignment 3, or at least that's the plan anyway, to draw some stuff. Right? So that's just an example of using objects. Right? Oh, there's a more sophisticated example here. Although I don't think I have it loaded, so bear with me while I find it. Again, you have access to all this source code, right? You just go somewhere, there's a link on OnQ that lets you download a zip file that contains the Eclipse project containing all the source code for the course. Okay, so bouncing ball is slightly more sophisticated. It does a bouncing ball, right? And so if you've taken any high school physics or your first year physics course, this is just using the equations for an ideal projectile so something falling under the influence of gravity to simulate a bouncing ball. You can see that it flickers a lot. So this class, this standard draw class that I'm using, it's not really designed to do this sort of stuff. It can do it, it just doesn't do it very well. If you wanted to actually make a nice drawing of this, you'd have to use some other graphics library. All right, here's an example of using Scanner. Again, I'm never going to ask you to use Scanner. If you want to use Scanner, so if you're playing around on your computer and you want to write a program where you want to type something into the program and have it read your input from the keyboard, this is one way you can do it. Right, so you're going to make a Scanner object. It's going to read this thing called system.in. System.in on most computers is hooked up to your keyboard. So this is the way that you would read keyboard input. There's a little loop here. So this program runs forever until you close the program. Right? It asks the scanner, do you have another line of input? That's what has next line means. Right? This always returns true, which is weird. So this basically sits forever, runs forever. It then asks the scanner, what is the next line of input, right? And then it simply echoes back what the user typed in. Right? And so if you run that, you can type something in, press enter, and it'll print back what you wrote. There's another example of using scanner. So this one, when you type in quit, it stops. It breaks out of the loop. Right? Otherwise, it's the same as before. So if you want to get keyboard input from the scanner, that's the very simple way of how to do it. All right, so we're going to skip over this lecture slide for now. This lecture slide basically, it's meant to prompt me to show you how to read the documentation for a class. Right? It's not very hard to do. So the problem with this slide is that when you actually look at the documentation for something, oh, great. We'll wait for Firefox. Well, I guess we're not going to wait for Firefox to update. Oh, here we go. All right, so the problem with reading the documentation is for the Java standard library is that you have to remember the documentation is written for professional programmers, and most of you are not professional programmers at this point. So it also assumes that you actually know the entire Java language. So reading this for new programmers is difficult. You'll see stuff that doesn't make any sense to you. Right? So let me just look at the string class. There's a better way to do this, by the way. I'm just doing this the dumb way. Not that one, this one. All right, so when you click on the documentation for a class, it always looks something like this. Depending on the version of the documentation you're looking at, it might look a little different. Right? They change the way it looks slightly, but it's always laid out in the exact same way. Right? At the top is a description of the class. Is the declaration of the class. So this tells you that string is in the package java.lang. All of this stuff here you'll understand in about, well, hopefully you'll understand in about 7 weeks. Right? That's how you actually declare, that's how the class is actually declared. Again, it's going to take a while before you understand what that means. Right? Then there's always a little description of the class. Right? So this tells you what strings are meant to do and what its basic functionality is. If there's any data that's available to the programmer directly, so if there's any fields, that'll be described next. Your constructors are then described after that. So you can see that string has many constructors. Right? And then you'll get a listing of all the methods. Right? Anything in blue you can click on. Right? So these are just hyperlinks. So I can click on car at, and that takes me to the documentation for car at. Right? If you go back, so when you read this, in the left-hand column, that's the return type. Right? So it tells you car at returns a car. Right? If it's a static method, the word static will be over here. Right? There's the name of the method. These are that's the parameters of the method. Right? So this says car at requires the programmer to give it an int. Right? And there's a one-sentence description of what the method does. Right? So it returns the car value at the specified index. If you want to know more about the method, you click on the method, and then it takes you to the detailed documentation. Right? And you can see here there's a whole bunch of other stuff here. Right? So apparently car at will also throw an exception. Right? So remember, it uses an index to access a character in the string. In Java, indexes are always between 0 and some positive number. So if you use a negative index, you get an index out of bounds exception. Right? If you use an index that's too large, well, you get an index out of bounds exception as well. And so reading the documentation is not difficult. Java documentation is actually pretty nice. So it always looks the exact same way. Once you get used to reading it, it's hard to read documentation for other languages. So for example, reading the Python documentation drives me nuts. But anyway, that's another story. All right, so there is the introduction to using classes. So the next lecture, I'm going to introduce another class. We're going to learn how to use that class. And then after that, we're going to learn how to make our own classes. Okay, so the next lecture is using lists. All right, so we know that Python has lists, right? We know that Java has something that sort of looks like a Python list, right? So we know that Java has arrays. By this point, assuming you finished assignment 1, you should realize that arrays in Java are harder to use and less flexible than Python lists. So the Python list is an example of what a computer scientist would call a data type. Right? And so the list data type is meant to represent a sequence of stuff. Right? So you've got a collection of items, and they all are arranged in some sequence. Right? So there's a first, then there's a second, then there's a third, and so on and so on and so forth. Right? You can add stuff to the list, you can take stuff away from the list, right? And you can access any element in the list, so on and so on and so on. Right? In CISC 235, the data structures course, you might see the mathematical definition of a list. Right? We're not going to look at that in this course. Java also has lists. So they have things that that have the same functionality as Python lists. Unfortunately, the way you use them is very different. So that's one of the main confusing points between Python and Java, right? Especially since you've taken Python and now you're transitioning to Java. Right? So in Python, you use a list. Everything's with the square brackets. It's very easy to use. It looks a lot like a Java array. Right? If I ask you to use a Java list, it now looks completely different. So you have to get used to using a list, and you have to remember that a list is not an array. Right? All right. So Java lists, they provide similar functionality to lists in Python. Syntax is very different, right? And it's going to look completely alien to many of you. There's another difference. There's another main difference in Java compared to Python. Java lets you pick exactly what kind of list you want to use. Right? Python, you just make a list and away you go, right? Whatever the Python library gives you for its list implementation, that's what you get. In Java, you can actually choose between different list implementations. So the one that I'm going to use in this lecture is this thing called ArrayList. Right? So to add to the confusion, this thing even looks like it's even named as though it were an array. Right? You have to remember it's not an array. Right? So it's a list. Right? Click on that link there. That'll take you to the documentation for the ArrayList class. So there is another kind of list that you might use. So it's called a linked list. We're not going to look at that until much later in the course. If we move fast enough, we'll actually implement a linked list. And hopefully, we'll be able to implement an array-based list as well. Right? But that's not until week 10 of the course or so. All right, there's another big difference between Python lists and Java lists. Right, so remember in Python, if you make a list, you can stuff whatever you want into the list. Right? So you put a string in, then you can put a number in, then you can put something else in, and something else, and so on and so on and so forth. Right? Many Python programmers take advantage of the fact that you can do this in Python to create data structures of their own. Right? So they'll use a list to store, say, information for a student. Right? The first element of the list will be a student number. The second element will be, say, the last name of the student. The third element will be the first name, and so on and so on and so forth. Right? The flexibility is nice, but it comes at a cost. Right? You have to remember what is in element one. What's in element 0, what's in element 1, what's in element 2, and so on and so on and so forth. Java doesn't let you do that. Java lets you make a list, but you can only store elements of a single type in that list. Right? So you can make a list of strings, and you can only put strings into the list. Right? You can make a list of integers, you can only put integers into the list, and so on and so on and so forth. So the element type that you use in a list is important. Right? It's significant to the language. So because it's important to the language, you need some way to tell a list that, hey, you're going to be a list of string. And so the syntax that you use is this, are the angled brackets. Right? So that's how you make an array list of string right there. Right? So on the left-hand side, we've got a variable t. Right? What's the type of t? It's big A array, big L list, right? Angled brackets, and then inside the angle brackets, that's the element type you want your list to hold. Right? So I want a list of string, so I make an array list of string. On the right-hand side, I need a list object to refer to. So I'm going to use new. Right? I'm going to call a constructor belonging to ArrayList. Now remember, in Java, the constructor name is always the same as the class name. right? And so our class name over here is ArrayList, so I'm going to write new ArrayList. In older versions of Java, you had to repeat the string, right? So here on the left-hand side, I say, hey, there's going to be a list of string. On the right-hand side, you had to repeat the string. And so the designers of the language quickly realized that this was very tedious. And so in a later version of the language, they let you omit the element type on the right-hand side. Right? And so I'm always going to write it like that. Right? So here T is an array list of string, and on the right-hand side, you can simply write new array list, angled bracket, round brackets, round brackets. Right? Remember, this is a constructor call right there. So to call the constructor, you need the round brackets after the name of the constructor. I'm just going to jump into Eclipse very quickly. Okay, so I've got this little class called ListDemo. So here I've made a variable T, right? I've said that its type is an array list of string, right? Notice that the Eclipse complains, right? And your compiler will also complain if you're using something else, right? If you hover over the error, it's going to say something. It's going to say array list cannot be resolved to a type. That's just Java. That's just the compiler's way of complaining. It doesn't know what the type array list is. And the reason it doesn't know what it is because you have to import the class. Right? We're in the package lists here. Right? And it turns out ArrayList lives in the package java.util, which is where many of the standard library classes live in this, for the purposes of this course. Right? And so you need to import you need to add import statement. So if you want to do it manually at right here, you would type import java.util.arraylist. Like that. Right? Now, if you don't want to type it in manually, Eclipse will fix it for you. So I'm going to get rid of that. If you hover over that error, you can just click on the little blue link, and it says import ArrayList. Which is great, except sometimes there'll be a class that there are multiple classes with the same name, and they will be in different packages. And so you have to remember to pick the right class. The one that's going to get most of you in trouble is the following. There's something called list. Don't use list yet in the course, right? Unless you know what it is, right? List is not a class. So this is one of the other confusing things in Java, right? For the reference types, there are things called classes. There are things called interfaces. List is what's called an interface, and we'll learn about those later in the course. The problem with this one is that if you wanted to use the interface type, normally you want the one from java.util. Unfortunately, there's two other ones. Right? There's that one, and there's the third one. If you pick the wrong one, especially if you're new to Java, it'll import the type, but you won't be able to use the type the way you want it to. Right? These are three different types of lists. These are three different list things, whatever they are. And so they all they all have different functionality. So you have to remember to pick the right one. So you have to know that the one you want is from java.util. All right, so for now, be careful if you ever just see list on its own, right? You're going to want to import it from java.util and not java.awt. All right, so here we go. So here we have a variable t. What you have to remember here is that there's no list yet. Right? All you have is a variable. Right? So remember, both in Python and in Java, reference variables should refer to an object. Right? So you have a variable, but there's no object yet. Right? There's no array list. So a common error here that's made by Java programmers is that they'll try to use the list. They'll try to use t as though it were actually a list already. It's not. Right. So for example, you can ask for the size of a list. Right? How many elements are in the list? So that method is called size. Right? That's analogous to the length function in Python. Right? But if you write that and you try to run your program, you get this funny error. Well, actually, you get a compilation error, which is good. Right? So it says, hey, the local variable t may not have been initialized. Right? The compiler is trying to tell you you don't have a list yet. Right? Because you don't have a list, you cannot ask for its size. Right? So so if you have a variable that refers to a list, you have to remember you need a list object for it to refer to. Right? So here I need something like, or something similar to the following. Right? So I need to make a new array list. So I have to make the object. Right? Remember, that's the first thing that you do when you want to use an object. You have to make one. Right? So I'm going to use new, right? Call the array list constructor, and that gives me a new list. Right? Notice here, Eclipse is happy now, and so now I can type out, I can print out the size of the list. Right? And so now you get 0. So that constructor there makes an empty list. Right? Gives you a brand new list object. There's nothing inside of it. All right, confusing thing number, I don't know, 50 by now, right? In Java, you cannot make a list of int, or a list of little d double, or a list of little c char. So one of the limitations of Java's lists is that you can't make a list of primitive type, where the elements are of primitive type. Right? So for example, if I try to write array list int, the compiler is going to complain. So array list or int u, like that. Right? So as soon as you write that, Eclipse underlines the int and it says, hey, syntax error, insert dimensions to complete reference type, which again means nothing to any of you, right? It's complaining it doesn't know, it cannot make an array list of int. Right? That's what it's complaining about. Whoa, sorry. And you might think that's crazy, right? The language has ints, why can't I make a list of int? And so the answer is because, believe it or not, they did not put lists into the language until version 5, I believe, of the language. So there were 4 major versions of the language before they thought, hey, maybe we ought to put this list type into the language. And by that time, it was too late to easily introduce a list type that can store primitive types and reference types. So the designers of the language had to work out a solution. Right? And so the solution was, for every primitive type, there is a corresponding wrapper type in Java. Right? So if you ever see this term wrapper class or wrapper type in Java anyway, typically what people mean is that it's the class that corresponds to the primitive type. Right? So little b Boolean, true, false. Right? It has a corresponding wrapper class called big B Boolean. Right? Int, right, has a corresponding wrapper class called big I integer. Also notice that for some reason the wrapper class names are not always the same as the primitive type names. Right? For char, it's big C character. For a double, it is capital D double. Right? So every primitive type has a corresponding wrapper class. And so you can make a list of the wrapper class instead. So if you want a list of int, you just make a list of integer instead. All right, so the wrapper classes are also, they get special treatment from the compilers, just like string. Well, not exactly like string, similar to string. Right? So remember, string, you have string literals. Right? So put something in double quotes, you get a string object. Right? The wrapper types aren't quite the same, but they're almost the same. So here I've got an int I, its value is 1. Right? If I want the integer object whose value is also 1, right, you can write big I integer, give it a variable name. Right? Now remember, everything I just told you said, hey, you always call new. Well, that's not true for the wrapper types. Right? For the wrapper types, you don't have to call new. Right? If you have an int, it turns out you can store an int using the variable j. Right? And so what the compiler does is it takes I, or sorry, it takes the value of I, so 1, right? It calls one of the integer constructors for you automatically, right? So this is, again, it gets special treatment, right? The compiler doesn't normally do this for you. So it turns the value of I into a big I integer object whose value happens to be 1, and it stores a reference to that object. Right? It lets you go the other way as well. So if you have a big I integer object, right, you can store its value in an int variable. So in other words, the compiler calls a method belonging to j for you that gets the value of j and stores it in k. Right? And so converting an int to a big I integer is called auto-boxing. Converting a big I integer to its corresponding primitive int is called auto-unboxing, or just boxing and unboxing. Right? And you can do the same thing for all of the wrapper types. So for example, okay, so double D is equal to 1.0, and big double W is equal to D. So that works just fine. Right? The primitive value of D, the primitive variable D, its value is 1. Right? I can turn 1.0 into a big D double object and store it in the variable W using auto boxing. Right? I can go the other way around. Right? I can get the value of W value equals W, right? By writing that. Right? So the compiler tries to make your life easy. Right? It lets you convert between a wrapper type and a primitive type automatically. Oops, sorry. Okay, there you go. Right, and so when you want a list of primitive type, you just have to remember you can't do it. You have to make a list of the corresponding wrapper type instead. So if you want a list of if you want a list of int, you make an array list of integer. Right? If you want a list of double, you make an array list of big D double. And if you want a list of char, you make an array list of big C character instead. So when you do this, you can more or less, almost always, pretend that you have a list of primitive type. Right? So here is my list of integer. I'm just going to pretend it's a list of int. Right? So if you want to add something to the end of a list, you call the method add. Well, you call one of the add methods, I guess is the better way to put that. Right? So t.add 100 adds the value 100 to the end of my list t. And so t is a list of big I integer. That's not a big I integer. That's an int. Right? So Java takes the int value, wraps it up in an object, and stores a big I integer reference in t. Right? If you want to get the first element out of the list, right, the method is called get. Right? So in Python, you would normally use the square brackets. You can't do that with Java. It's a list. It's an array list in Java. Right, square brackets are for arrays. Right, so to get the element out of a list, you have to call the method called get. Right, pass in the index 0. Right. Now remember, this is a list of big I integers, so this returns a reference to a big I integer object. Right, but you can store the value of that object in an int variable. The compiler simply auto unboxes the object to give you back the int the value here. So you can more or less pretend that your list of integer is a list of int. Right? There's only one thing that might cause problems. Right? And so the one problem that you might run into is this method called remove. Right? Remove lets you remove, the problem is there's two versions of remove. So remove lets you remove an object from a list by passing in an index. So here we're going to add 100 to the list, and then I'd like to try to remove 100 from the list. Right? Unfortunately, this doesn't work the way you want it to. I'm just going to delete this quickly. All right, so there's my list T. I'm going to add 100 to T. I'm then going to print out T. Oops. Like that. All right, so if you print out a list, you get the, it's complaining about something. It's a list of strings, sorry. It's now a list of integer. Okay. So when you print out a list, you get something that looks like what you get when you print out a Python list. So you get square brackets, then you get the elements of the list separated by colons and a space. Right? So if I add one more value to the list, remember add always adds to the end of the list. you now get the list 100 and 200, right? So now you have a list of two integers. All right, so what happens if I try to do t dot remove 100? Right. So you might guess that you're going to remove the 100 from the list. So you get the list 200, right? Unfortunately, that's not what happens, right? Instead, your program crashes, right? And it complains there's this index out of bounds exception, right? And so it says index 100 is out of bounds for length 2, right? If you click on any, so if you click on down here, it'll tell you where in your class, here, right? So if you click on that line there, it'll take you to the line where the exception was thrown, right? And so what's going on here, so if you look at what remove actually does, right there, right? It says that remove takes in an index and it tries to remove the element at that index, right? So here we're trying to remove the 101st element from the list, right? We're trying to remove the element at index 100. There is no element at index 100, right? There's only two elements in the list. So there's an element at index 0, there's an element at index 1, there's not one at 100, right? And so you get an exception in this case, right? And so that's there's the problem with remove. Now, if you wanted to remove the value 100 from the list, right, what you have to remember is that this thing is a list of integer. It's not a list of int. So if you wanted to remove the big I integer 100, you have to tell the compiler you want to remove the big I integer 100, right? And so now you have to do something funny. So the easiest way in this particular case is to do something like this. Right? So make a big I integer variable, give it whatever name you want, right? And so to remove stores the value 100, or is the big I integer object that, that has the value 100, and now you can remove it from the list, right? And this will work correct. This will work the way you want it to. Right, and so when you remove the 100 from the list, you just have the list that has the 200 in it, right? And so this is an interaction with two things in the language, right? So Java lets you have a method, lets classes have methods with the same name. So you can have multiple methods all having the same name. There's two versions of remove, right? One takes in an int, one takes in an object reference, right? So the problem is when you write t.remove100, the compiler thinks you want the int version of the method, right? So remove the element at a given index, right? If you call the one that takes in an object, then it says, oh, you want to remove the object that's equal to, in this case, 100, right? And so now it does the thing that you wanted it to do in the beginning, right? So you have to remember there's two versions of remove. Yes? Can I cast what? So, you have to be careful with casting in Java. So the problem is that sometimes the cast does what you want it to, and sometimes it doesn't. But let's see if it does what you want it to in this case. So it seems happy with this, right? I kind of wish you hadn't asked this, because now people are going to write this everywhere, and it's going to be wrong. Oh, this is going to, hang on, I have to comment out this one, because I already removed 100. So let's see if this works. And so the answer is yes. You have to be very careful with this. Right? Again, the language treats the wrapper types specially, right? So the wrapper types get special treatment in this case. So the language will let you cast from a primitive value to its corresponding wrapper class. Right? The problem is a lot of students are going to want to cast from something to something else. So they're going to want to cast an int to a string, for example. That doesn't work. Right? So for example, a lot of students will want the string equal to 100. And so they'll try to do something like the following. Right? That doesn't work. Right? So you have to be very careful with the cast operations. Right? So when you're casting, I mean, for most of you, what you should, for the purpose of this course, right, the only casts you probably ought to be using are from, say, double to int. So you have some floating point value, you'd like to convert it to an integer value. right? That you can cast int, no problem, right? Or you want to go the other way around, which you don't have to do, but you don't need the cast, but you can do that as well, right? Never cast something to a string. It's never going to work, right? If you want to convert something to a string, use concatenation instead. So there's another question over here. Yes?
If you had a multiple of the same integer,
Yeah. It removes the first instance of the, yeah. So I guess we should do that. What do we have right now? Let me remove the casting one. Put this one back in. And let's put in some more 100s. All right, so now I've got 100, 200, 100, and then I'm going to remove one of the 100s. So there's your 100, 200, 100, and so you can see it removes the first one. Right? If you hover over the remove method, it'll tell you removes the first occurrence of the specified element from the list. There was another hand over here somewhere. Yes?
Previously, you just had
Yes. I removed the reference to.
So you casted it, and then you also use the reference.
Oh, yeah. Okay, so. No, the cast works, so let's look at to remove. So it removes the first occurrence of the specified element from the list if it is present. If it doesn't contain the element, the list remains unchanged. So that's what happened there. So that's so to prove that it works, I should comment out that line, and it does work. Yeah. Any other questions? All right. Whoa, sorry. Oh, here's the other way that you can convert an int value to a big I integer. So the integer class has a method called value of. It's a static method, so it belongs to the class integer. Right? So to call the method, it's big I integer dot value of, and then you can pass in an int, and it will convert the int. It'll give you back the integer object corresponding to an int. Right? So that's the other way to do it. Right? If you wanted to, you could also call a constructor. So you could write integer I equals new integer 100, which also works. Right? That's probably the more concise way of doing it. All right, so there's a whole bunch of list operations, just like there are a whole bunch of list operations in Python. Right? And so here's a little table that summarizes, actually it's better if, maybe not. All right, so I think the tables are the same except the first version of the table gives you the English description of what's happening. The other version of the table, gives you the Python code. So if you remember what the Python version does, this table is handy. If you don't remember what the Python version does, you might want to refer to this table instead. Right? So how do you make a new list? You write it like that. You call a constructor. Right? So new array list. Now you have an empty list to work with. Right? If you would like to know is the list empty, you can write is empty. Right? So T is empty. So I'm going to clean this up a bit again. So I'm going to go back to a list of size 0. Right, so there's size. Right? You want the size of a list, it's t dot size round bracket, round bracket. Right? Not to be confused with the length of an array. Right? The length of an array is a dot length, no round brackets. Right? Is the list empty? So Boolean boo. Oh, sorry. Right. Right, so there's my new list. It has size 0. Is it empty? Yes. Right. As a Python programmer, that's annoying, right? Because remember in Python, you can simply write if t. So the fact that you have to explicitly call a method and remember what the name of the method is slightly annoying if you're a Python programmer. Number of elements in the list we've already seen, right? It's just the size method, so t dot size. Right? Again, don't get this confused with the plain old array, right? For the plain old array, it's a dot length. You would like to add something to the list, right? So normally when you use a Java list, Java array list anyway, you always add to the end, right? It is the most efficient way to add an element to a list, right? So you just call add, right? And you pass in the element that you would like to add. So this is a list of strings, so we pass in the string hello, it sticks hello onto the end of the string, right? We already saw back here, for a list of integer, you would just write t.add, say 99, right? And again, you can look at the size and so on and so on and so forth, right? So now if I ask, is it empty? Right. So now I'll ask the list, is it empty? Right? It's going to say, no, it's not empty. Right? If you ask for its size, it's going to say 1. How do you get an element out of the list? So to get an element out of the list, you use the get method. Right? And so the get method is analogous to the square brackets in Python. You give it an index, right? In Java, it's always between 0 and and the size of the list minus 1, right? And that returns a reference to the element in the list. So if I want to get the first element out of my list here, it's going to be, I'm going to use big I integer here. T get 0, like that. Right? Right? So what's the first element in the list? Well, it's 99. Right? The annoying thing, and one of the annoying things, again, if you're a Python programmer, is there's no easy way to get the last element out of a list. Right? So in Python, you just use the index -1. Right? In Java, if someone just hands you a list and you want the last element, you've got to do something like the following. T get. So what is the last index for a list? It's the size minus 1. What is the size of t? It's t dot size, right, minus 1. Right? Being able to write minus 1 here would be super nice. Can't do it. Right? What is the last element of a list of size 1? Well, it's the same as the first element. Right? So this is also going to be 99. Right? So remember, last element of the list, no easy way to do it. You have to call size and subtract 1 to get the correct index. Okay. So I guess the other the other basic or fundamental operation for an array list is setting an existing element. Right? You have to remember, setting an existing element. Right? You cannot set a non-existing element of a list. Right? So for example, a lot of students will try to add something to an empty list by writing t set 0. You can't do that. Right? Set replaces an element in the list. Right? So if I'd like to replace the first element in the list, I can do t set 0 with something else, minus 100. Right? And now I can print out the list again. Right? And so now you're going to get the list that has one value in it, and its value is minus 100. Right? Right? So again, remember, cannot set an element that doesn't exist. Right? So we've got one element in our list. So if I want to set or add something to the end of the list, I cannot write t set 1 that. Right? So if you try that, you're going to get an exception. Right? Index 1 out of bounds for a list of length 1. Right? If you want to add something to the end of the list, it's add. Right? If you want to replace an element, it's set. Right? All right, so it's 20 after. I guess I have to stop there. So we'll look at the rest of the table in the next lecture.